This conference will now be recorded.
All right. So, does anyone have any questions before we get started? Anyone, any questions that I can take? Anyone, any questions out here that I can take before we can get started? So, yesterday we started off with something called as virtual networking. We started off with something known as virtual networks. We just introduced what is called as a network. We said, how can you use this network in order to protect resources like a storage account and everything? So, let's dive deep into it. So, yesterday I created a network. And I was telling that a virtual network is nothing but your own private space on the cloud. It's your own space. Just like you're going ahead, buying a land somewhere and telling that this is my piece of land or this is my piece of, let's say, area. And you establish a fence around it and you probably build a house or something like that inside that. So, to protect your resources, like a storage account, you can place all your resources inside this particular network and they can be protected. So, let's go ahead and see how do you create this particular network out here. So yesterday we created one simple network. So let me go ahead, recreate another network today. So again, in the creation tab of the network, it's telling Azure Virtual Network is a fundamental building block for your private network, and Azure VNet enables you to, let's say, VNet enables many types of resources such as virtual machine to securely communicate with each other, the internet and the on-premise and all that stuff. So it's telling a lot of things, and most importantly, it's talking about one key ingredient called security. It's about security out here. It's about protection. It's about resource protection out here and etc. So what I'll do is I'll just go ahead create something known as VNet RG, some resource group. I'll just scroll down and here I'll give the details of the network, the meaning the name of the network. I'll say this is first VNet, something like this. And again, the region of the network. Very importantly, this is what I was telling. The region of the network and the region of the resources you want to protect with this network. Let's say, for example, a storage account have to be in the same region. You cannot have your network in a different region and a storage in a different region. You cannot do that. Both have to be in a same region out here. And I'll say, okay, fine. Let me go ahead and create the same thing in today in North Europe. So I'll say just North Europe. So in the first page, I'm just going in and selecting what is my subscription, what is the resource group name, what is the network name, and which region my network actually belongs to. After that, I'll say next, and then I have something called as IP addresses out here. Very important. It's asking me the virtual network address space specified in one or more address prefixes in something known as CIDR notation, example, something like this. See, what you're doing is that you're going to the cloud and you're telling the cloud provider, you know what, I need some space. I need my own private space in order to go ahead and create or in order to go ahead and protect my resources. Let's draw the same thing out here in a physical world. Okay, you go to a real estate broker and you tell him that I need space, I need some amount of land or something like that. What is the first question he's going to ask you? What type of, okay, okay, anything else, any
Like
basic thing, any basic question?
the way we want space.
Space, size, yes,
Location,
sorry. Please, your voice is very
area,
behind. Area, space, yes, area. Meaning, how big or how small of a land do you need, right? That's the basic question anyone is asking. So you go ahead and tell that, you know what, I need a land. So they'll say, okay, fine, how big or how small of a land it is. So you, in normal physical world, you talk it up. Guys, can you please go on mute? Thank you. Okay, in a physical world, you'll talk about things like, you know what, I need a land of about, let's say, some X amount of square yards or something like that, right? In a virtual world, same thing. You're again creating a space of your own. Now Azure is asking, okay, fine, boss, I'll give you a space. but can you tell me how big or how small of a space is it? And you'll need to tell how big of a how small of a space is it in terms of something called as address space. Just like you have square areas and all that stuff in a physical world, you have to tell Azure that, you know what, I need this big of a network or this small of a network. And the notation is something like this. I'll go and create something called 10.0.0.0 /16. This is the notation of something called as an address space. It's telling you, okay, fine, it is 10.0.0.0/16. And just click on this white space out here. And it's telling you 10.0.0.0/16 is going to give you what? 65,536 addresses. It's telling you, I'll give you 65,536 addresses in this space what you create, which means you can technically take or you can hypothetically take 65,536 resources and place it inside this space. Meaning here I put one storage account, you can put around 65,536 storage accounts inside it. You can protect this. It's that big. It's that big of, let's say, an address that you're taking. But how is it calculated? What exactly we do to calculate all these things out? Let's look at that. Let's talk about address spaces, also known as CIDR notation, classless interdomain routing. CIDR stands for something known as classless interdomain routing out here. So let's do one thing. I'll say 10.0.0.0/16. Let's take the 16 aside. Let's talk about what the 16 really is. And let's look at this one. 10.0.0.0. See, this 10.0.0.0 is for you and me to understand what this is, or is for you and me to understand what space this is, or how big or how small of a space this is. But when you look at a server, when you, let's say, talk to a server, a computer, this is not what it looks like. For a computer, what a computer does is that a computer firstly converts all these things into its own language called as a binary language. It's a binary language out here. So if I just go to Google search and say IP to binary converter, there's something known as IP to binary converter out online out here. So what I'll do, I'll put an address called 10.0.0.0. This is the address that I have. They convert it into binary. This is what you get. So even in your C programming language, something that you learn in your school or college, something like that, you just take the number called 10.0.0.0 divided by 2 until you get 8 octets. I mean, until you get 8 things out here. So I'll just copy this out, go into my, let's say, notepad. I'll paste it out here. Again, the first 10 is represented by 00001010. 0 is represented by 00000000. This is represented by this. This is represented by this. How many digits that you see here in each and every block?
8
8. And how many of those 8s you see? 4.
total. Yeah.
That's 4. That's the reason these are called as IPv4, Internet Protocol version 4 addresses out here, because 1, 2, 3, 4, 4 separations, and each and every dot is separated by how many? 8 digits. That's the reason
Yes.
each and every block here is called as an octet, octet, 8. And if it means 8, what exactly this 8 means is that each and every block can carry 8 bits of information. 8 bits of information. What do I mean by this? Very simple. You're creating an address space. You're putting multiple resources inside that address space out there. Each and every resource needs to talk to each other. Here, each and every resource will be using these octets to carry information, to let's say carry forward the information out here as such. So 8 bits of information out here, which makes it how many totally? 8 into 4,
32.
32 bits of information.
32
Meaning
octet
that
is
32 bits of information is something that you can carry in one address range or in one address out here, which is 10.0.0.0, something like this. But again, I ask, okay, fine, you know what, this is 32. Can I use all the 32 bits of information? Can I go ahead use all the space completely? So Microsoft says, no, you cannot do that. There needs to be something known as a subnet masking that is coming into picture. That's what you see here, /16. So when you create something called as a CIDR, let's say block, which is classes interdomain routing block, or the address space out here, there is a body or there is an organization which governs this. Meaning, just like when you go ahead buy a product in the market, you look for something called ISO tag to say that the product is good or bad or something like that, right? And if a product needs to be certified by ISO mark, they have to have certain standards telling that these are the standards and all that stuff. Same thing, when you come down to let's say your IP addressing, you have something called as a convention called RFC 1918 standards, which is the standard for private network address space, which is telling the internet networking private something is let's say is used for local area networks and all that stuff, and it's telling all these are governed and etc. Now, according to the RFC 1918 standards, you cannot do or you cannot directly go ahead and do something called 32. You cannot say I want the entire thing, or you cannot say sorry, you cannot say I want the entire thing out here. You need to put something known as a subnet masking. When I say subnet masking, it's asking me how many bits I am ready to leave. How many bits I'm ready to leave, I don't want to use. And here I put 16. 16 is 8 plus 8. 8 plus 8 is 16. Calculating from the left hand side to the right hand side, which is my left to my right. Here it is telling, you know what, the first two bits or the first two blocks, this is something that you cannot change. The rest two is something that you can change. Meaning, in this block, if the first two cannot be changed, 10.0 is static. 10.0 out here is static. So I can say the first IP address. Till now, I did not talk about the IP address. I'm talking about the address block. Address block gives you the IP addresses out here. The first IP address can be 10.0 always constant .0.0. First IP address. Second IP address can be 10.0. This 10.0 will always be constant .0.1. Second IP address. Third IP address can be 10.0.0.2. Fourth can be 10.0.0.0.3. And the last in this series can be 10.0.0.255.
6.
This is
Yeah,
the last.
255.
This is let's say 255 last, which means if I calculate from 0 to 255, how many addresses am I getting, guys? No, from this one, 0 to 255, 250,
256.
256, including 0,
Yes.
Yes.
256. Now I'm telling 10.0, this is the only thing that I cannot change, right? So I change the last number 0, and then it went to 1, it went to 2, and etc. Can I also do 10.0.1.0? Can I do this? Yes, I can do this.
Yes, we
I
can
can
do
also
it.
do 10.0.2.0. I can also do 10.0.3.0.
1.0.
So on so forth to 10.0 dot, let's say 255.0 is something that I can do. This is again 255, 1 to something. I can also do a combination of 10.0 dot, again 0.0. I can say 10.0 dot 1.1, something that I can do. I can say 10.0 dot 1.2. I can put this combination. I can again get something like 10.0 dot 1.255, which is 256 addresses. I can again do something like 10.0 dot 2.1, 2.2, 2.3, so on and so forth. I can put this as static. I can again get 256 addresses. In that probability and combination, the amount of addresses I get here is 256 into 256, which is nothing but 65,536 addresses, and that's the reason you find this number here. I think it is 65,536. Again, an easier way to calculate it, not to get into all this math, etc., is this. Standard 0.0.0. The maximum octets or the total number of bits of information is 32. And how many you are reserving? 16, which becomes something like 2 to the power of 32, which is total, minus 16, which will give you again 2 power 16, nothing but 65,536 out here as such. This is how you do the calculation. Again, question is that do we have to do all these calculations? No, I don't have a calculator with me all the way that I'm going. No, not, I don't do that. Easiest way to do this is just go to an address or just go to a website called cidr.xyz, which will help you in calculating let's say the address space visualizer. So here I'll just put it as 10.0.0.0 forward slash 16. What's the count that I get? 65,536. Again, everything that you see in a color cannot be used. You cannot change it because masking is what? 16, which means these two cannot be changed. But these two can be changed. That's the reason you get this particular number. Now, one question is that what if I reduce this number? Go ahead, please.
Suresh Teja here. I have a quick question. Like, who would be the giving these IP number initially from, there will be a particular series, right? From where
Mhm.
this series needs to be started from. So
Right.
usually, correct me if I am wrong, usually based on the series, what the client require, based on the client requirement, we will go ahead and use the a series. And
Correct.
as you mentioned, the power of the calculation, yes, we do the power of calculation also. And there will be a three public, private, NAT of these IPs, right?
Mm-hmm.
And again, we go into the IP calculator, and if we just plug in the R IPs, and
Mm-hmm.
it also shows from where the next has to be started from. Correct me if
Correct.
I'm
It
wrong.
does. That's correct.
Yeah. So the IP's address will be given by the client only, right? The where the
The
series has to be started from.
IP address, either the client or if you are, let's say, working with an Azure architecture team, they will have to give you.
Uh-huh.
So it's either
Okay.
the client
Got
or
it.
the Azure architect. They will have to give you or
Oh,
they will have to tell you how big or how small should your address actually become. And we
right.
as a DevOps
Right.
engineer, we implement it out. So implementation
Okay.
is us, but address they're gonna tell you.
So how many servers they want actually, right? Instead of IP address, we
Correct.
can say it. How many servers they need?
How
Let's
many?
say example 200, 300, or 500,000 servers. How many they want?
Mhm.
Based on that, we will calculate this IP address, and they will mention also how many you want in a public and private and as well NAT as well, right?
Correct.
Oh,
So based
got it.
upon all
Thank you.
these things, you calculate this particular, let's say, IP addressing out there.
Oh, got it, Suresh. Thank you.
Okay. Yes. Any more questions here, guys? All right.
Was an
So
IP ad
good,
so
please.
by default there was reflecting an IP address. You have deleted and replaced it with the new IP address. So can we go ahead with the default IP address, or every
Can you go
time
to the default
this
IP
must
address?
should
Not
be
really. We don't. We don't really go to the default IP addresses. Default IP addresses is Azure, which is telling you that, you know what, Azure giving you a suggestion, telling that, okay, fine, you can go with this particular IP address or something like that. But we don't usually go with that particular ranges. We go ahead, put our own ranges out there, depending upon, things
so
like.
every time
Go ahead, please.
so every time we have to go and change the IP address. You
It
mean that?
depends. That's what it just depends on what is your requirement. Do you really need this big
Okay.
space? Do you really need, let's say, this big space, or do you want something smaller? Or what exactly are you trying to do with this particular network? Depending upon those questions, your address range changes.
Okay. Okay. Thank you.
Any more questions here, guys? Anyway, any questions till you? Right. So the question that I have is that, what if I reduce this number? What if I reduce this out to 15? Will the address space increase or will it decrease?
It will decrease.
It will decrease. Let's see. 15. Will it decrease? Increase? Why is it? You are putting, instead of 32, sorry, instead of 16, you're putting what? 15, which becomes 2 power what? 17. Simple math, right? 32 minus 15 or 32 minus 16 is 16, right? 32 minus 15 is what? 17. 2 power 17 will of course give you greater number. Simple. So as
Yes,
in
yes.
when you reduce this number, you are telling that, you know what? I want to also occupy this bit. I also want to, let's say, change this one. Now it's saying, okay, fine. Your address count is 131,072. If you further reduce it, again, do you see? Further reduce it. 13, you're occupying everything. So now this is 52,000 or 524, 288, 5 lakh something change out there. So can I do something like one? Because these are the number of addresses that I get, right? It's around 2 crore 14 lakh 74,008, something like that. It's so many addresses that I'm actually, kind of getting out here. These many addresses that I can actually get out here, which means that I can secure these many resources. My address space can be as bigger as possible. I can say, okay, fine, you know what, Azure, I'll do that. I'll put a one. Selling what? Not a valid CIDR address block. Again, coming back to the RFC 1918 standards, you cannot use everything. There is a maximum limit that you can use. And for a 10.0.0.0 address, which is called as a single class A network, a single largest class A network, the largest block of address can be what? 10.0.0.0 forward slash what? 8, which means that you can only start your addressing from 8. So that's the reason if I put 1, what is it telling you? Please use what? 10.0.0.0 forward slash what? 8. So I cannot put a 6, I cannot put a 7, I can do a 8. This will work out. This is the largest address that you get when you go for a single, or when you go for something known as a class A addresses. Class A addresses always start with 10.0.0.0. This is a class A CIDR address block. This is called a class A address. Again, if you go for a class A address, the security that you get and also the price that you pay is higher. Both are higher. Security and the price are both higher. There is also something known as class B address, which is a little smaller, wherein it is telling you that you know what, the largest address block that you can go for is what, 172.16.0.0/12, which can give you how many IP addresses? 1048.576. So I'll take this, I'll copy this out. Do you see now I have a class B address? I'll have to pay less when I create a class B address as compared to a class A address out here. And also I cannot do a /8 here. Why can I not do a /8 here? Why can I not do it? Not valid. Why? Why is it not valid?
It's already
Because
starting from 172 dot.
172.16.
It should start with what?
172.16.
It's 172.16 exactly. Largest address block can be what? 12. I cannot do something like 11 or something like
8.
10 or something like 8. I cannot do that. It has to be 12.
16.
And you also have something called class C addresses out here. Class
See,
C network addresses out here, which is 192.168.0.0/16. Now class C addresses, right? These are very popularly used. If you look at, let's say, class C, these are very popularly used in routers. You buy a router, right? You'll have, if you turn the router back, they'll have something known as an address out there, which will look something like 192.168.0.1, the IP address of a router. So these are all used, let's say, in those kind of devices out here. So what I'll do, I'll stick with my address, which is 10.0.0.0/16. I'll start with 16 block. Now I'm telling that my virtual network should be this big, just 10.0.0.0/16, which can give me up to what, 65,536 IP addresses out here. Now I'll say, okay, fine, Azure, go ahead, create this for me. Azure tells, okay, fine, I'll create, but hold on. You also need to tell me something known as a subnet. Virtual networks are also known as VNets. A VNet, in a short form, we call them as a VNet, virtual network out here. You also have something known as a subnet, a subset of a virtual network. Very simple. You're going to, again, just drawing the comparison. You bought a land. You want to, let's say, construct a house right now. You have to also tell how many rooms the house has. How do you divide your land into, let's say, living room, dining room, and all that stuff? You also have to tell what is the partition, and each and every partition will have its own space. Let's say I want to divide it into 1/4 of this particular house and all that stuff, right? These small partitions inside this particular virtual network are called as subnetworks. Let's look at that. Let's come here, just scroll down. It's telling what? Add a subnet. I'll say add. Saying subnet name, I'll say subnet 1. Telling subnet address range. It's telling, okay, fine. Can you tell me how big or how small do you want your subnet to be? Very importantly, see, please observe this. Your address is what? 10.0.0.0/16, which means these two are constant. Your subnet address can also can only and only start with 10.0. Your subnet address always have to be within the VNet address range. Very simple. You bought a land of 1000 square yards. You cannot tell that the subnet or the smaller room, or you say you are now constructing a room, you cannot tell that, you know what, please construct a room of 1200 square yards, because it's not possible. Your land is only 1000. So you have to make sure that the space you're constructing inside the virtual network stays inside the address range that you're going for. So now I'll say it is 10.0. 10.0 is always constant. I'll say .0.0 /24. Why am I doing a 24? Why not 16? Can I do a 16? Yes, I can do a 16. I can do a 16. But simply means that the entire address is occupied by one subnet, meaning a huge house with just one room. Not, let's say, not ideal. Can I do a 15 year, guys? Do you think I can do a 15? Yes, no, maybe. No, why is it not?
Because we have a limited of 16, and
Exactly. We
based on
limited it
the
16.
go ahead. I'm sorry. Go ahead.
No, no. Please go ahead. Not a problem.
I was just mentioning, like, where we have, I mentioned like 1,000 square yards. It is costing like,
Mhm.
16 with a 16 of IP,
Exactly.
dot by 16.
Exactly. And this is what it is telling you. The
Yeah.
subnet address range 10.0.0.0/15 is not contained within the virtual
Virtual
network address
networks.
space. It's
Right.
not contained, meaning it's going above and beyond your virtual network. So, which means your subnet address range can be anything greater than or equal to 16. So 16, 17, 18, 19, 20, all these things greater than or equal to, I'll put a 24. Because of my, let's say, ease of calculation, I'm putting it as 24, which gives me 10.0.0.0/24 as a subnet address range, which is my subnet 1. 10.0.0.0/24, which means if I'm putting a /24, it means that these three are constant. Now I'm putting what? 24, these three are constant. Then what can be my addresses right now? What can be the address that is coming out of it? Guys, following this, I'm able to see a lot of blank faces. If you're not able to follow, let me know. I'll re-explain it. This is very, 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 very important. Any cloud provider you go, wherever you go, this concept will come. This concept will come down. This is a very, very important concept out here. Yes. What's the confusion here?
2 power
Anyone
32
who
minus 24. Is it
2 power 32 minus 24, which is
correct?
2 power 8. What is the
You can
largest
get
number you can
250.
put it inside of? Yes, just a second. Yes, 256. I'll just come down. What is the largest number in place of 24? When you say largest number, do you mean 23, 22, or do you mean, let's say, 25, 26, 27? We'll talk about what is the largest number. I'll come to the largest number as well. But if I put a 24, if I just, let's say, put a 24, what am I going to get? 2 power 32 minus 24, which is what?
Yes.
2 power 8. It's 256 addresses. Again, which is calculated how? Which is calculated how? It is 10.0.0.0. First address 10.0.0.1. Second address 10.0.0. These three are constant always, because you have what? /24, which means 8 plus 8 plus 8. 8, 8 and 8. 3 are constant out here. 24 out there. So I'll say these are constant. So I'll say it is 10.0.0.2. So on so forth to what? 10.0.0.250.
250.
55, which will give you what? 256 addresses. This is giving you what? 256 addresses. Now, what is the largest that I can go for here? What is the largest? That was your question. Can I go for 30? If I go for 30, what will happen? 2 power 32 minus 30. 2 power 2. How many IP addresses?
4.
4. Let's try that. Let's go back into our Azure portal. If you increase the subnet masking, it will decrease the number of addresses that you get. If you decrease the subnet masking, it will increase the number of addresses that you get. But let's do that. Let's say 30. What is it telling you? Smaller than or equal to 29. Reason being, whenever you create a subnet, whenever you go ahead and create a subnet out here, let's say my subnet is 10.0.0.0/24. Whenever you create a subnet, you will get, let's say 2 power 8. This is 256 minus 5. This minus 5 is called as cloud reservation IPs. They are called reserved IPs. Every time you create a subnet, 5 IPs are reserved, meaning 5 IPs you cannot use it. Which means how many addresses that you're going to get here? 251 usable IPs, meaning in this subnet, you can create 251 servers, 251 storages. You can place so many resources out here as such. Why is this reservation? Again, if you just go back, do you now see 251 plus what? 5 Azure reserved addresses. These are for multiple purposes, like let's say if in the future Microsoft wants to roll out an update, they would need a subnet. So they reserve a subnet out there. There is something called communication broadcasting. Within the subnet, a lot of resources needs to talk to each other, for which they need an address. So they'll block an address out there. So multiple reasons why the subnet is actually reserved. And these are all your Azure reserved IP addresses out here, which means you cannot go beyond 29. Reason being, if you go to for 29, it is what? 2 power 32 minus 29, 2 power 3, 8, which is 3 plus 5, or 8 minus 5, which is 3 addresses. If I go for 30, it is coming as what? 2 power, let's say 2, 4, 4 minus 5 minus 1. You cannot have a minus 1 address. You at least need to have one address out there. That's the reason the smallest block that you can go for is 29 out here. So for ease of convenience, I'll say 24. I'll say add. I have added one subnet, which means out of the 65,536. Now let's see. VNet is what? 10.0.0.0/16, which is 65,536. Out of which I am now slicing out a subnet. I'm telling, let me occupy some amount of space out here. So I'm drawing a line here, and I'm taking some space out here from my virtual network and assigning it to my subnet 1. I'm telling this is the space that subnet 1 is now occupying with 256 addresses out here. So let's come back. Subnet 1 is taking 10.0.0.0/24, getting around 256 addresses out here, which means how many are left? 65,536 minus 256. The simple calculation, which means I can create multiple subnets inside the same VNet. I'll say add. I can also say subnet 2. Now tell me, if subnet 1 is 10.0.0.0, what can be the address of subnet 2? Can I again say 10.0.0.0/24? Exactly. You can say 1. That's right. Meaning you only use this 0, 0. Can I say 1.0 for 24? This will be my second subnet. If I want to create one thing, that's a subnet 3. I can say what? 10.0.2.0 for 24. If I do this, I can go at the max up to what? 10.0.255.0, 0 to 255, 256 subnets with 256 addresses each, which is again 256 into 256, comes down to the same number, 65,536 out here. So I'll say, okay, fine. This is how I create my subnet. I'll say next, security. I'll say tags, review, and create this out here. So now I'm creating a virtual network with 3 different subnets inside this particular virtual network out here. And I'll say create. And using these subnets, now this is how you can do it. When you create things like a storage account or something like that, they attach these resources, attach themselves not to the network, but to the subnet of the network. And the subnet is directly attached to what? The virtual network out here. This is the alignment. So you have a virtual network, you have a subnet inside that virtual network, and this subnet is attached to your resources. This subnet is attached to your resources out here as such. Yes, any questions with this? It's not a resource group. You cannot attach a virtual network to the resource group. You can attach a virtual network or a subnet of the virtual network to things like a storage account, virtual machine, SQL servers, and all that stuff. The resources, not the resource group. Because resource group is nothing but a folder. You cannot, let's say, put a virtual network integration on the resource group level, but on the resource level, yes, you can do that. Yes, any questions still here?
Yeah, actually, why subnets become mandatory?
Why subnets become mandatory? Very simple. You have, let's say, a huge space. Don't you tell how the space will be divided? Very simple.
Yeah,
The thumb rule of any cloud, basically. Yes, good.
uh, okay, we will divide. If not divide, also we can use entire space. No. So my question is, if
But still, you
we
have to tell a
re-
subnet. But still, you have to
okay,
tell, let's say, a subnet out there. Very simple. Why resource group is mandatory to create anything? You can literally create resources, right? But you need
yes,
to group resources, and that's the reason you have a resource group concept.
yes, yes,
Same way, in a virtual network, the thumb rule is that your virtual network should at least have one subnet, because subnet now
okay,
becomes the resource which gives you the addresses.
okay,
Virtual network gives you the space, subnet gives you the actual addresses that you can consume.
okay,
And the reason, again, it's a very valid question. Why do you need so many subnets out here? Why do you think you need so many subnets? Reason being, what you can do going further is that you can do something known as a subnet delegation. Meaning, I can say, you know what, subnet one type of a subnet is for one particular resource, like a virtual machine. Or the other type of subnet is for another particular resource called storage account. Third subnet is for another resource called SQL servers. And I can apply my firewall rules on top of it, telling that
okay,
this specific traffic can come into subnet 1. This specific traffic can come into subnet 2. So it is a watertight separation so that you can apply your rules and policies accordingly.
okay. Got it. Thank you.
Any more questions here, guys? Okay, sir, can we create cloud space for both public and private IP addresses in the same virtual network? Public addresses, I'll talk about it. Public spaces, yes, you can create it, but normally you go ahead and say create all these things for private address spaces out here. Can we say subnets are created for data privacy? I would say virtual network itself is created for, let's say, data protection and privacy out there. Subnets, just go ahead, divide your virtual network inside it. And about public spaces, I'll talk about that. I'll talk about what public spaces are and all these things out here as such. Yes, any more questions, guys?
Suresh, can we do the subnets for like 10.0.0.1, 10.0.0.2? Can we do
You
that
cannot do it.
sequence?
No, you cannot really get that sequence. Reason being, if I put something like that, right? Let's say I'll say subnet 3. If I say it is 10.0.0.3 /24, it's telling you know what it overlaps with the subnet 1. Why does it overlap with the subnet 1? Because here you have 10.0.0.0 first address, second is what 10.0.0.1, third is 10.0.0.2, fourth is what 10.0.0.3. So you cannot reuse it again. This number
Got it.
again, if you reuse it, so it will become again, it will overlap with, let's say, the entire subnet as such out there. That's the reason it says, you know what, don't use this, rather use 3.0, 4.0, 5.0, and all these things out here as such.
Thank you, Kiran.
Okay, any more questions here, guys? So today I just want to cover the theory of subnets and virtual networks. We need, let's say, a good amount of time to understand virtual networking and etc. And that's the reason I did not rush it yesterday. I want to make sure that we discuss it in very great detail. And in the next session, we'll understand how to use these subnets. What do we do with this one? What is a virtual machine and all these things out here as such. All right. And very quick reminder, guys. So we will not have a session tomorrow, day after, anyways, Saturday, Sunday, we don't have one. And we don't have one on Monday and Tuesday. We'll be meeting on, yes, we don't have on Monday and Tuesday. We'll be having 21, 22, 23, and 24. Saturday also we'll cover it out. So last Sunday and this Saturday is something that I'll cover out with this. All right, so that's it from my end today, guys. I'll give you your 10 minutes back. I have some work, so I need to finish it out there. So we'll meet on Wednesday. And what I want you all to do in between this gap is that we covered a good amount of automation. We did a good amount of automation using PowerShell, ARM templates, and everything. Please revise it. This is going to be very, very important. Please revise it. And one more question that I have is that we created a virtual network subnets and everything using the Azure portal. Can we create it using an ARM template? What happens when you create it with the ARM template out here? Please check that out and let me know what that happens. Okay. Thanks, guys, and meet you all on Wednesday. Thank you.
Sir, I have one small doubts.